Today we will discuss average power supplied to an oscillator, that is average power supplied to an oscillator. We know that power is the ratio of work upon time, that is power is equal to dW upon dt, or work may be written as F into dx, because work is F into dx upon dt. This is F, and we may write this dx by dt as V, velocity. So, power may be written as the product of force and velocity. In case of forced simple harmonic oscillator or motion, the force is equal to F naught cos of omega t, because we are doing power, and power is force into velocity, where force is equal to this, that is real part of force, because we are considering only its real part. And in case of velocity, the real part of velocity is F naught over Zm into cos omega t minus phi. So, this is force and it is velocity. So, we will put the values of force and velocity, that is real component of force and velocity, is here, and to get power. So, power is equal to product of force and velocity. But our topic is average power. This is power, but we have to find an average of the power. So, what is formula for average power? It is equal to power into dt integral over integral dt. You know that this is formula for average power. Average means the integral of power with respect to time upon integral of time from 0 to t, that is for one cycle. 0 to t means whole cycle. So, value of power is F into V into dt 0 to t over the integral of dt become t, and when we are applying the limit, it will become t minus 0, that is t. Okay, t minus 0. Now, we will put the values of force and velocity. Force and velocity, that is the values, the real component of force and velocity, we will put the values here, and it will become 0 to t. The force means F naught cos omega t into velocity means F naught over Zm cos of omega t minus phi into dt, and 1 by t is written as 1 by t and the outside from the integral. Okay. This is average power. Now, we will do the integral of these terms. So, we will take common, F naught is common, F naught into F naught square over t into Zm. Okay. And integral of 0 to t, limit cos omega t into cos omega t minus phi dt. Now, we will expand this cos a minus b. So, F naught square upon t into Zm integral 0 to t into cos omega t cos a minus b. We may write this cos a cos b plus sin a sin b. This is expansion of cos A minus B. It is cos A cos B plus sin A sin B. Okay. Now, it will become f naught upon t into Zm, f naught square upon t into Zm. Now, we will separate these two terms and it will become integral 0 to t cos omega t into cos omega t cos square omega t cos phi into dt, this one, okay, plus integral cos omega t sin omega t, that is sin omega t cos omega t into sin phi into dt 0 to t. Okay, there are two terms. Now, we will solve further f naught square upon t into Zm, and we may expand or write this cos square omega t as 1 plus cos 2 omega t upon 2 integral 1 plus cos 2 omega t upon 2. You know that the value of cos square theta is 1 plus cos 2 theta upon 2 into cos phi dt 0 to t, and plus integral, this is sin theta cos theta. So, we multiply with 2, divide with 2, it will become 2 sin theta cos theta, that is sin 2 theta sin 2 omega t into sin phi dt upon 2. So, it will become the linear function, that is 1 by 2 plus this and so on. Now, further f naught square upon t Zm into, it will become 1 by 2 integral 0 to t 1 by 2 cos 1 by 2 cos phi into dt. The first term will be separated and the second term is integral cos 2 omega t cos 2 omega t upon 2 into cos phi into dt, okay, second term, and the third term remain as it is sin 2 omega t upon 2 into sin phi into dt 0 to t. So, there are three terms consisting of integral part. Now, we will solve the integrations of these terms. First of all, it is f naught square upon t into Zm, okay, and 1 by 2 and cos phi, these are constants, and it will be outside the integral, and integral of dt is small t and limit become 0 to t, okay, plus in this case 2 is constant, cos phi is constant, and we will take the common cos phi upon t and integral of cos 2 omega t into dt. So, we know that integral of cos 2 omega t dt or integral of sin, this one, 2 omega t dt for whole cycle, they will become 0, means the integral of cos 2 theta and integral of sin 2 theta for whole cycle, for one cycle 0 to t, it is always, both are 0. So, second term becomes 0, third term also becomes 0. So, you may solve this cos 2 omega t by simple integral method. You will find that the answer of cos 2 theta and sin 2 theta is always 0. So, the second term and third term, they will vanish, only first term remain there. So, further it is f naught square upon t into Zm into half into cos phi into t minus 0, that is capital T, this one, and t is cancelled with t, and finally we will get average power is equal to f naught square over 2 Zm into cos phi. So this is the formula for average power of force oscillator, where this cos phi is called power factor. I think you have already studied this power factor in the lower classes, power factor cos phi. If we will put this value of cos phi from the value of tan phi, then this formula may be converted into the simple form. That is, we know that tan phi is equal to omega m minus s by omega upon r. Okay. And if you draw a right angle triangle from this tan phi equation, so this is triangle. We know that tan phi is the ratio of perpendicular upon base. So this is perpendicular, this is base. It means this perpendicular is omega m minus s by omega and base is r, because perpendicular upon base is tan phi and this angle is phi. Okay. If it is r, it is omega m minus s by omega, then by using Pythagoras theorem, this hypotenuse become r square base square plus m omega minus s by omega whole square under root. Okay. And you know that it is nothing, it is impedance Zm. This is impedance. So this triangle is called impedance triangle or right angle triangle. So you may find the value of cos phi from the triangle. From triangle, we may find the value of cos phi. What is cos phi? Base upon hypotenuse, r upon under root r square plus m omega minus s by omega whole square, which may further be written as r by Zm, impedance, mechanical impedance, Zm, impedance mechanical. So this one. So on putting the value of cos phi as r by Zm, here we will get power average is f naught square upon 2 Zm into r over Zm. Okay. Cos phi is r upon Zm. Now this power is written as f naught square into r over 2 into Zm into Zm square. So this is simple form of average power. So this is formula for average power. Now similarly, we will again discuss the variation of average power with omega, with driving force frequency. As we have already discussed, the different variations of displacement amplitude with omega, phi with omega, velocity with omega, acceleration with omega, and now it is the variation of average power with omega, with angular frequency. You know that we will discuss by taking 3 cases. First one, omega tend to 0, that is at very low frequencies. Second, at high frequencies, omega tends to infinity. And third case, omega is at resonance. So in case of power, the resonance frequency is same as omega naught, means frequency of undamped oscillator. Omega naught means s by m under root. This one. This is the value of omega naught. So when you put the value of omega tend to 0, then on applying omega tend to 0, this power becomes 0, because you know that Zm is equal to r square plus s omega m omega upon minus s by omega whole square under root. When omega tend to 0, then this term will dominate because it is finite value, it has finite value, m into 0 means 0, 0 value, 0 finite, and this term will become infinite because something s over 0 become infinity. So this term will dominate and overall Zm become s by omega. This Zm become s by omega when omega tend to 0. So power average become f0 square r over 2 into s by omega because Zm is taken as this one, s square by omega square. So at last omega is there. When we put omega tend to 0, so 0 into something, power becomes 0. This is power also becomes 0 when omega tends to 0. Similarly, you may find when omega tends to infinity. So in second case, when omega tends to infinity, then this second term will dominate. For infinity, this term will dominate. So Zm is equal to m omega. Okay, Zm is taken as m omega. So it will become power average f0 square r upon 2 m square omega square. So again omega is there. So at last we will put omega as infinity here. So something upon infinity become again 0. So again omega tend to infinity, average power again become 0. And the third case, when omega tends to omega naught, you know that. So when omega, we will put the value omega as omega naught means s by m, then you will find that Zm become r because this term will become 0 because we will put omega as s by m under root, here s by m under root. Ultimately they will cancel and remaining term is r square under root, that is r. So Zm become r at resonance. So at that case average power become f0 square r over 2 into Zm square means r square. So this r cancel with r, and finally this average power is f0 square upon 2r. So this is third point. So there are 3 points: omega tend to 0, power 0; omega infinity, power 0; omega omega naught, power this is finite. So we plot the graph between omega and average power. It is 0, it is omega naught, it is infinity, and at 0 power 0, this one. At infinity power again 0, and at omega naught power is finite, it is maximum power. Let it be f0 square by 2r, it is maximum. So at omega naught this point will come here, and we will complete this graph, you will get this answer. So it is same as the graph of velocity. You know that in case of velocity, such type of graph is obtained, which start from 0, ends at 0, and reaches at maximum at resonance frequency. So this is average power. If we draw any line in this graph, that line will cut this graph at 2 points. So let the first point, the frequency corresponding to first point is omega 1, and the frequency for second point is omega 2, and the difference in frequencies omega 2 minus omega 1. So this is frequency omega 2. It has more value as compared to omega 1 because it is less, it is more. So difference between two frequencies is called band width. Is called bandwidth. So what is bandwidth? The difference in two frequencies at single value of power. If we draw this line exactly at the center of minimum 0 and this maximum value, this is center. If we draw this line at center, then the corresponding points, this one, it is called full width at half maxima. Full width at half maxima. half maxima means it is maximum value, this one, let it be any 10. So you may draw a line at 5 means it is at the midpoint, half maxima, maximum half value from maximum, and the frequencies, two frequencies at this value, the difference between two frequencies is called full width at half maxima, or in general this is called bandwidth. So this is all about average power and its variation and bandwidth. Thank you very much.